of 4-4 lesson. This will not be on the quiz. At 4-4, we're going to be, the biggest thing about math is that we have to start recognizing the differences, and they're just subtle little differences. Like the difference, one of the classes had a hard time. We talked about the difference between this and this, and we've talked about this throughout the year. Do you see how these all look very similar? There's a 2, there's an x plus 2, there's a 2, there's an x plus 2. And in this one, you can distribute the 2 and you get 2x plus 4. But in this case, you cannot distribute it. That is wrong. In this case, you would have to do x plus 2 times x plus 2. And now you distribute like this, and which would get you to an answer of x squared plus 4x plus 4. If you try to do it this way, you would end up with just x squared plus 4, and you're completely missing this 4x. So we've got to start recognizing the differences between when we can distribute, when we don't distribute, and what they mean for each case. That similar thing's going to happen today. We've been talking about multiplying fractions, and the way we multiply fractions is top times top, bottom times bottom. We see if we can cross simplify anything, which we can't in this example, so 1/8 would be our answer. We talked about dividing fractions, which we go ahead and change to multiplication. We see if we can cross simplify, which we can, and then we end up with 2/1 or 2. But today we're going to start talking about this and how you subtract these two, or how you add them together, which have different completely rules than what we've been studying in the past. Now, why am I bringing this to your attention? Look how similar these things look. The only difference between this problem, this, and this are the signs in the middle. And kids don't pay really that much attention to them. And then what they do is they mix up the rules, and they kind of do the adding one and kind of combine it with the multiplying, and then they cancel crap out, and they kind of just do a mix of all of it together, and they end up going, I hate fractions. When fractions really aren't that bad, the biggest thing is you got to know when to apply the rules. And then once you know the rules, they're really easy to deal with. Does that all make sense to you?
Yeah.
So let's learn the rules for adding. I think I already previewed this with you the other day. So we're just adding on to this. The biggest thing is when we add fractions, they have to have common denominators. When we subtract them, they must have common denominators. Totally different than when we multiply them. So I love this problem. Why? They already gave me common denominators. So I'm just going to, like we had here, once we have common denominators, we add the tops, 3, keep the denominator, 4. So in this same exact thing with nastier fractions, we're going to add the tops, we're going to combine these two things together, but in the end, we're going to keep that denominator. So the denominator, since it is the same in both of them, we can just keep it in the end. And then we would just combine like terms. A positive 8x and a negative 4x is going to leave me with 6x. A negative 5 and a positive 8 are going to leave me with a positive 3. And then I want to try to reduce. You cannot, this is a common mistake, cancel these out. That is wrong. Just like we did last time, we cannot cancel anything out when it's in standard form, which both of these are in. We must factor them. Well, these guys both have a 3 in common, so I can make this a 3 and then 2x plus 1, and then over, and then this is already factored, which is 2x plus 3, and hopefully you can see that 2x plus 3 does not cancel out with 2x plus 1, so actually either of these could be the answer that you might see on a multiple choice test. And technically they might tell you that x is not allowed to equal negative 3/2 because that is the restriction, but some books don't do that because there was nothing that canceled out, so you can still see that that x can't be 3/2 because I didn't cancel anything out. If I would have canceled something out, you have to make sure you put that restriction in there. But since nothing canceled out, no restrictions aren't seen, so it's kind of okay to leave it. Some books put the restriction in, some don't. Next question, going to be a little bit different. It says to find the sum, which when we hear find the sum means that we're going to add the two fractions together. And you're going to notice the first thing I'm going to do is again factor everything. So I'm going to go x plus 3 over. You better start seeing that this is a difference of squares and you got to see it fast. We cannot take forever factoring. So that is a difference of squares. X plus 1, x minus 1, plus 2. And then this turns into x. These are same signs. Both negative, two numbers that multiply to 2 but add to 3, 1 and 2. And then I'm going to highlight for you right here. If you notice, let's look at what they have in common. Both of them have an x minus 1. But we need them to be the same denominator. So this one has this that one doesn't have. So the green from the left side, the right side doesn't have that. And then this has this x plus 2 that the other side doesn't have. So I'm going, okay, how do I make this denominator the same as this? Well, just like we did when we had regular fractions, sometimes we can't make the 3 become a 2 and we can't make the 2 become a 3. So we have to multiply both fractions by some number so that they become the same thing. And what we did is we would times this by 3, but whatever we did to the bottom, we had to do the top, and that made this become a 6. And then we had to times this by 2, but then we had to times this top by 2. And then we both made them have a 6 as denominators, and then a 3, and then a 2. And now since they have common denominators, we add the top and keep the bottom. We're going to apply this same thing to these nastier numbers over here. So we're looking at it, we're going, okay, we both have an x minus 1. So we both have that. Now, this one is missing this x plus 2. So how can I make this have that x minus 2? I just multiply it by the x minus 2. And what did we say the rule was? You can multiply the fraction by any number you want to, as long as you multiply the bottom and the top by the same thing. Because really, what number am I multiplying this by is a 1. And whenever you multiply any number by 1, we're not changing the value of the half. We're just changing the way it looks. Both of these are worth 0.5, but they just look different. I'm doing that same thing over here. I'm going to multiply by what it's missing, which is the x minus 1. But to be fair, if I do it to the bottom, I have to do it to the top as well. So now what's this new denominator? It is x minus 1, it's an x minus 2, and it had already the x minus 1. Oh, this is a plus 1, sorry. Oh no, sorry, the x plus 1. Hello, Mr. Martin. Get it together. It's missing the x plus 1. So now you see all three of them, x minus 2, x plus 1, x minus 1. By the way, the order down here does not matter. It can be changed all the way around. They just have to both have the 3 different bubbles. Now let's see. And if you have a question you need to ask me, you can ask me right now. Just interrupt me. It's okay. What is this fraction over here missing that this one had? And hopefully you can see it's the x plus 1 that it's missing. So I'm going to multiply the bottom by an x plus 1. But to be fair, if I do it to the bottom, I have to do it to the top. And then now this denominator has an x minus 1. It has an x minus 2. And it also has the x plus 1. And now you can look at this and go, they have the same denominators. But when I come back up here, I got to remake this top. And so I have to multiply this out. Well, since this is a bubble and this is a bubble, you have to distribute. So x times x is x squared. X times 3 is a 3x. I'm going to hold on to that for a second because this times this is going to be a minus 2x. And I knew these guys were going to combine. And a 3x and a negative 2x is just 1x. And then a negative 2 times a positive 3 is a negative 6. Then I do the same kind of thing over here, except all I do is distribute the 2 because it's only one term up there. So 2x plus 2. And finally, I do the last thing, which is combine the tops, keep the bottom. So I already know what my bottom is going to be. It's going to be x minus 1, x minus 2, and x plus 1. And finally, combine like terms. There's no other x squared, so it's just x squared. I use that. I'm going to combine a x and a 2x and get that to be 3x. And then finally, a -6 and a +2 make a -4. And then finally, I have to see if I can simplify this. And so what happened is I need to I need to, what in the heck is going on with my computer? I need to factor this guy. So I'm going to look at that and I'm going to go, okay, this says different signs. This says the bigger one's positive. Two numbers that multiply to 4 but subtract to 3. 4 and 1 over x minus 1, x minus 2, x plus 1. And then what I do is I can say, wait, x is not allowed to equal, it can't equal 1, it can't equal 2, it can't equal -1. And then I cross these out because they have them both in common. And so my final answer would be x plus 4 over x minus 2, x plus 1. With the exclusions, it's not allowed to be positive or -1 or 2. And that would be my final answer. Does that make sense? Mm-hmm. Questions on that?
Are we going to go over this again next week?
Yeah, a little bit, but this is going to be the majority of your lesson. So you need to ask me if you need something. Let me help you out here. What's bothering you, Nina?
I think I get it. I just feel like I need a little bit more practice.
So you will have homework to try it, but you can always go back to the YouTube video and kind of follow. It's going to be the same process, right? What was the first thing I did? What I have to do to both denominators?
Make them equal.
Before I could do that, look at the form here. Look at the form.
Oh, factor.
So I factored both. So that's going to be the first thing, right?
Right.
Then after I factored, I looked and I said, okay, they both have an x minus 1. So I'm like, okay, I'm not worried about that, right? This one had an x minus 2. This one didn't. So I gave it an x minus 2 by multiplying the bottom and top by it, right?
Mm-hmm.
This one had an x plus 1 that this one didn't. So I gave this one it by multiplying the bottom and top by that same thing. Notice all I did is rewrote the denominators both times down here, just the same denominator. And then how did I get this top? You have to distribute it, right? This is old stuff. That's why we've talked about how math kind of sucks, because you should be able to multiply this times this. And all I did is this times this is x. This times this is 3x. This times this is -2x, which makes a positive x when you combine them. And then this times this is a -6. I distributed the 2. I came down here. Now, once I have the same denominator, you just combine the tops, which means I combined like terms. Once I got here, I factored the top to see if anything canceled out and then simplified. So I can understand you don't feel like you could do it, but go back and use my video and kind of like, okay, go to the top of this question that we did and look at your problem and go, okay, what did you do first? Okay, he factored. Okay. When you do your homework question, factor first. All right, then hit play again. Oh, okay, next thing he did was he saw what they have in common and then figured out what he needed to multiply each of them by. Okay, do that, your step on your question. Does that make sense, Nina?
Yes, thank you.
Keep following mine and do what exactly I do, but you're just using different numbers. And then after you do it 5 or 6 times on homework, you'll be able to do it without watching the video again. That's how homework should be done in math. All right, The next thing we're going to do is subtract fractions. The same exact thing happens for subtracting fractions. We just have to make sure they have the same denominator. Now, there is one tricky part with them, and we will talk about that when we get to it. But other than that, it's the same thing as adding fractions. What is a part of a fraction that is not written but needs to be understood? Because we're going to need this for later on. What is in a fraction, especially like up here, that's I don't write, but we need to understand they are there. They're imaginary, but they are there. Does everybody understand that there are parentheses around both of those things that I don't write, but they are there? That's going to come into key later on. All right, first thing I'm going to do is factor both my denominators. So this one right here, this says different signs. This says the bigger one's negative. Two numbers that multiply to 16 but subtract to 6, 8, and 2. It's nice to know multiplication tables. This says same numbers. This says you add them, and they're both plus. So I need two numbers that multiply to 8 but add to 6, 4, and 2. And then we write the tops. What do we notice that both of them have? If we look, they both have an x plus 2. So you're going, okay, they have that in common. This one has an x minus 8. This one doesn't. So I'm going to make x minus 8. I have to multiply the top and bottom by what it's missing, the x minus 8. This one has an x plus 4 that this one doesn't have. So I need to multiply this one by an x plus 4. Does everybody understand that process so far? What I'm doing is I'm making them have common denominators. Both of their denominators are now going to be x plus 4, x minus 8, x plus 2. X plus 4, x plus 2, x minus 8. Remember, it doesn't matter the order, it just matters. There's an x plus 4, x plus 4, x minus 8, x minus 8, x plus 2, x plus 2. These guys are the same exact denominator. The order doesn't matter. The other thing you should remember up on top now is because this has two terms and I told you they're both in parentheses, we have to distribute this stuff. So x times x is x squared. This times this is a 1x. You notice I kind of hold on to the middle term because this times this is a positive 4x. So a positive 4x and 1x makes a 5x. And then 1 times 4 gets me to a plus 4. And then finally distribute this thing. This times this is x squared. This times this is a negative 8. So I kind of remember that in my brain. And then this times this is a positive x. And a negative 8x plus 1x is a negative 7x. And then 1 times negative 8 is negative 8. Now, here's the tricky part. This is how I do this. I told you this was in parentheses for a reason. There's a subtraction sign here. What happened when we have a negative outside of parentheses? What did we teach you guys to do with that negative? And we were going to combine like terms. Before we can combine these two things, which is what I'm doing, I'm going to combine this with all of this. What did we do with this negative sign?
We distributed it through
So,
the
yes. So what am I going to do? Here's how I do this problem. What I do is I know that is a negative here, and I distribute it. When I distribute it, it's going to change all the signs that are up here behind it. So that's going to make this a negative x squared. That's going to make this a positive 7x. That's going to make this a positive 8. And when I distribute the negative, that makes this positive. And now I can do what I did just a second ago where I combine like terms. A x squared and a negative x squared are going to cancel each other out. A 5x and a 7x are going to get me to a 12x. A 4 plus a 8 is going to get me to a 12x, or 12, sorry. And this is all over x plus 4, x minus 8, x plus 2. Notice how much paper I've taken. Take your time. Write big. Use your space. Don't write small. Don't try to go left and right. Notice it goes one step, the second step, the next step, nice and easy. And then finally, I'm going to factor this because maybe something cancels out from the top and bottom. So they both have a 12 in common, and I'd be left with x plus 1. When I do that, I realize that there is nothing that can cancel out. None of these things cancel out, so this would be my final answer. If they did ask me to include the exclusions, that's fine. I can do the exclusions. It can't be -4, it can't be +8, and it can't be -2. And that would be my final answer. So if you notice, addition and subtraction is exactly the same. The only tricky part is right here. I said, you know what? With this subtraction, when my subtraction sign was here, what I did is I distributed the negative sign, which changed all these signs right here, and then I made that a plus sign. That's the only tricky part. Distribute that negative and make it a plus sign, then combine like terms to get to this. Questions? Any questions?